Hello, I'm Kripa from SNS College of Allied Health Science, Department of Cardiopulmonary Perfusion Care Technology. Today I'm going to take a topic on perfusion, principles of perfusion related to blood pumps. Actually, the characteristics of a blood pumps are controllable stroke volume and pulse rate, capable of producing wide range of outputs which are linearly proportional to the pulse rate and independent of afterload, minimal transfer of kinetic energy to the blood, parts in contact with the blood are disposable and smooth surface and are of simple design. And it includes divide areas of conductive to blood stagnation, turbulence or cavitation. Calibration is easy and reproducible, automatically controlled and operated for routine use with manual or battery operation potential in the event of power failure. Includes a monitor of actual versus predicted pump speed that halts blood pump flow when pump speed exceeds the set pump speed by monitor more than a fixed percent. There are two types of blood pumps. Pumps are displacement pump and rotary pump. In displacement pump, it includes roller pump, and in rotary pumps, it includes radial or centrifugal pump, diagonal pump, and axial pump. And no, there are two types of other perfusion, non-pulsatile and pulsatile perfusion. For non-pulsatile perfusion is known to have a detrimental effect on cell metabolism and organ function. The pulsatile perfusion more closely resembles the pattern of blood flow generated by the cardiac cycle and should therefore more closely emulate the flow characteristics of physiological circulation. The first one is roller pump. Roller pump is one type of positive displacement pump. It was patented in 1855 by Porter and Bradley, and in 1887 Allen patented pump design for blood transfusion. 1934 DeBakey et al. Made a modification to Porter-Bradley infusion pump to prevent the creepage of latex rubber tubing during blood transfusion. In 1959 Melrose proposed a more advanced design in the roller than running along the tubing held in place with a grooved black plate. The working principle of roller pump is the principle of operation of this pump. Two rollers placed opposite to each roll the blood through a piece of tubing. Rollers completely occlude the tubing and the pump is capable of generating both positive and negative pressures. A roller pump is relatively independent of factors such as resistance and hydrostatic pressure head. An occlusive roller pump depends on two main variables. The first one, the number of rotations of the pump and the internal diameter of the tubing. The structure it consists of, they consist of a length of tubing located in a curved raceway at the perimeter of travel rollers mounted on the end of rotating arms. They are arranged in such a way that one roller compresses the tubing at all times. Flow of blood is introduced by compressing the tubing, thereby pushing the blood ahead of the moving roller. Flow rate depends on the size of the tubing, length of the raceway and the revolutions per minute of the rollers. Depending upon the number of rollers, roller pumps are classified as single, double and multiple roller pumps. For single roller pump, only one roller is available and it rotates on a 360-degree to eject out blood. Used in 1950s and 60s, more pulsatile flow is achieved. The tubings are placed as 360-degree. For double roller pump, two rollers are available, 180-degree rotation. Backplate is 210-degree semicircular backplate. The occlusion is done alternatively by the two rollers and non-pulsatile flow. For multiple roller pumps using three or more rollers, curvature of backplate can be reduced to 120-degree or less. Not used nowadays because this causes more hemolysis. The tubings used for roller pumps are made up of silicon, polyvinyl chloride or latex rubber. PVC is mostly used because of its durability and acceptable hemolysis. Latex rubber Latex rubber disadvantage it causes more hemolysis and also can cause reaction. Most pump loops are made of silicon or PVC to a lesser extent of latex rubber. Spallation, the release of plastic microparticles from the inner wall of the tubing as a result of pump compressions. Advantages of roller pump. Reusable with the inexpensive disposable part, easy to sterilize, simple flow rate determination, variable stock volume for different size particle, the just occlusion clause, lowers hemolysis and than non-occlusive pump. Disadvantages: blood trauma, tubing spallation, possibility of circuit disruption and termination from excessive line pressure, particulate microemboli from tubing spallation, possibility of massive air emboli, contraindicated for long-term use because of tubing wear and blood trauma. Thank you.